Public goods are non-excludable and non-rival in nature, which means that individuals cannot be effectively excluded from their use and the usage of such goods by other individuals. Also, will not reduce the availability of such kind of goods. The most important characteristic of public good is that consumption by one individual does not actually reduce the amount available to be consumed by the other individual. Public goods are those types of goods which are provided by the government through budget, like highways, public parks, defense, ports, fresh air, national security, common language, flood control systems, lighthouses, street lights, etc. These goods are not created in market and they are being provided by the government with the help of various provisions in the budget. These types of goods are also known as social goods and they are not consumed by an individual person, but such types of goods are being consumed collectively by the society. For example, in case of highways, only one person is not using the highway facility, but it is being used collectively by several persons. As public goods play a very important role in the economy, so their provision also become a major part of concentration for various economists because the market mechanism is not sufficient and not reliable in providing public goods because of the preference revolution problem present in the economy. Various mechanisms and theories have been developed by various economists to study the demand and preferences of the public for public goods. Demand revealing is a process where collective decisions are being made and which is being designed to choose the option of greatest value, and in this process the option is being identified by giving participants a chance to report about their intensities of their preferences honestly. Thus, it creates the incentives for people to reveal their preferences for public goods in a truthful manner. The demand revealing schemes for public goods have been studied by various economists like Edward H. Clarke, Groves, and Ledyard. The term DR, that is demand revealing, was described by Edward Clarke in 1972, and in 1975 Groves and Loeb worked on this process independently. DR has also been called as pivotal mechanism in economics. After studying this module, you shall be able to know about the demand revealing mechanism, learn the Clarke provision of public goods, understand the Groves mechanism, learn the Ledyard mechanism of public goods. Let us now study about the Clarke-Groves mechanism. In 1972, Edward H. Clarke introduced a taxation scheme for the consumers to reveal their true preferences for public goods. In this mechanism, everyone truthfully reveals their preferences even if they are not required to do so. Clarke demand scheme, also called as the pivotal mechanism, which gives each user of the public good the choice of either to leave the outcome as it is or change its cost equal to net loss of others. He explained this concept with the help of quasi-linear utility function. The Vickery-Clarke-Groves mechanism is a direct quasi-linear mechanism XP where XV is equals to arc X summation I into Vx, PV is equals to summation j, which is not equals to 1, Vj into x into V minus I minus bracket close is equals to summation j, which is not equals to 1, Vj x into V. This equation can be explained with the help of the following example. The government is deciding to install number of public benches in the town. There are 3 beneficiaries x, y and z with 4 alternatives available, that is n is equals to 0, 1, 2 and 3, where n is the number of public benches. The government objective is to provide good quality benches to the people living in the town. The following is the table representing the cost and the social net benefit of those benches. As social net benefit is maximum at 2, that is the socially efficient number. Net benefits with equal cost share is being presented in the following table. If n is equals to 1, the total cost is 120. Hence, cost share for each is 40. The private net benefit for x is then 60 minus 40, which is equals to 20. Similarly, for y and z and n is equals to 2 and 3. Now this example is being explained when Groves and Clark tax is being applied. Grove-Clark taxes. Person X. The following table is been given, and for the resident Y and Z, the following table is given. You can see from the table that person X is not playing an important role. Without him, the net benefit is maximum at n is equals to 2. With him, the net benefit is maximum at n is equals to 2. So, his tax is 0. For person Y, following are the 2 tables. Person Y is, however, playing an important role. With him, the net benefit is maximum at n is equals to 2, and without him, the net benefit is maximum at n is equals to 3. Thus, Y tax is the difference between the sum of net benefits of others at n is equals to 3 and the sum of the net benefits of others at n is equals to 2. That is, 135 minus 130 is equals to 5. Y is paying the tax because his report changes the decision from n is equals to 3 to n is equals to 2. Now the following is the table for person Z. You can see from the table that person Z is also playing an important role. With him, the net benefit is maximum at n is equals to 2. Without him, the net benefit is maximum at n is equals to 1. Z tax is, however, the sum of the other benefits at n is equals to 1 and the sum of other benefits at n is equals to 2. That is, 60 minus 50 equals to 10. Net benefits with taxes is represented in the following table. Post-tax net benefit from this scheme is 10 for x, 40 minus 5 is equals to 35 for y, and 120 minus 10 is equals to 110 for z. Incentives for truthful revelation is been presented in the following table. Here it is to note that from the table X net benefit is maximum at n is equals to 3. Now looking at the three tables provided above, X role is very important. Without him, the sum of net benefits is maximum at n is equals to 2. His report will change the decision from n is equals to 2 to n is equals to 3. So, he has to pay the tax, which will be equal to 160 minus 120, which is equals to 40. If X lies and does not report truly, then the net benefit from n is equals to 3 minus tax. Therefore, 35 minus 40 is equals to minus 5. If X truly reports, then the net benefit will be 10. Thus, no point arises that X should tell a lie. Thus, this was the VCG mechanism for public goods. Moving further, we now study about the Groves-Ledyard mechanism. Groves and Ledyard jointly worked hard and gave the demand revealing mechanism, which they called by the name an optimal government. This mechanism used to formulate the rules of a game in which the amount of taxes and distribution of public goods is being determined by the government as a result of those messages which the individuals choose to communicate. Though the government has no independent knowledge about the preferences and the individuals are aware that giving signal of their preferences to the government will be beneficial for the government, and it might be possible that Pareto optimal situation in the economy. The Groves-Ledyard mechanism is defined for general equilibrium and applies to smooth preferences. They discovered this scheme in 1975 and work out this mechanism in quasi-linear form, which is given as Vx bracket Ax comma B is equals to Ax plus Fx bracket B. This is termed as equation 1.1. The advantage of Clark tax is that there is a dominant strategy for the equilibrium, but the disadvantage is that though this tax system was leading to Pareto efficient situation, but some amount of private goods are being wasted in this mechanism. Suppose there are X consumers and there is one public good and one private good. Each consumer has initial endowment of Vx units of private goods. Public goods are being produced at a constant unit cost of Q. The government will ask each consumer X to submit a number of either positive or negative Mx. The government will supply an amount of public good, which is B is equals to summation X Mx. Now, Groves-Ledyard mechanism is presented as minus Mx is equals to 1 by n minus 1 summation y is not equals to 1 into My. This is termed as equation 1.2. To be the average of the numbers submitted by persons other than x, the function can also be defined as Rx bracket n is equals to 1 by n minus 2 summation y is not equals to x bracket my minus m minus x into 2. This is given as equation 1.3. The thing that is being noticed in equation 1.3 is that Rxn depends on the minus m minus x for y not equals to x, but does not depend on my. These expressions will help in making a balanced budget when vector messages sent by individual consumers are m is equals to m1 minus mn. The Groves-Ledyard mechanism will impose a tax on individual x equal Tx bracket m is equals to alpha x q summation nk is equals to 1 mk plus lambda by 2 bracket n by n minus 1 bracket mx minus mx bracket close into 2. This is given as equation 1.4, where alpha x and lambda are arbitrarily chosen positive parameters and summation k alpha x is equals to 1. If the vector messages is m is equals to m1 minus mn, then consumer x utility will be Vx minus Txm plus Fx summation nk is equals to 1 mk. This is given as equation 1.5. In case of Nash equilibrium, each consumer x would be choosing mx to maximize in equation 1.5. The first order for maximizing is Fx bracket summation k mk bracket close is equals to lambda mx minus 1 by n summation k mk plus alpha x q. This is given as equation 1.6. Now summing up the equation, summation k alpha k is equals to 1 and summation k fk bracket summation k mk bracket close is equals to q. This is Samuelson condition for efficient provision of public goods. The tricky thing to depict is that the total revenue collected by the Groves-Ledyard mechanism is equal to the cost of the public good. Thus, to find out the total of the sum of the taxes collected from each consumer x, then it is being found out that summation nx is equals to 1, tx bracket m is equals to summation nx is equals to 1, alpha x q summation nk is equals to 1 mk plus lambda by 2 summation nx is equals to 1 into n by n minus 1 bracket mx minus m minus x bracket 2 minus rx bracket m bracket close. This is given as equation 1.7. Now fitting with the sum of quadratics, the result will be summation nx is equals to 1 into n by n minus 1 bracket mx minus m minus x into 2 is equals to summation nx is equals to 1 rx bracket m bracket close. This is given as equation 1.8. Therefore, equation 1.8 can be simplified as follows. Summation nx is equals to 1 txm is equals to summation nx is equals to 1 alpha x q summation nk is equals to 1 mk. This is given as equation 1.9. Since summation nk is equals to 1 and mx is equals to b and summation nx is equals to 1 alpha x is equals to 1, this equation is further simplified as follows. Summation nx is equals to 1 txm is equals to qb. This means that revenue is exactly covering the cost of the public good. Now Groves-Ledyard mechanism is presented in quasi-linear utility form. It is of great interest to analyze the Groves-Ledyard mechanism that the nature of this mechanism is applied in quasi-linear utility where each consumer x has a utility function Vx bracket axb bracket close is equals to ax plus fxb. This type of model gives a unique solution as given by Clark. This type of equilibrium can be easily computed and described. Since Fk is less than 0, then equation 1.1 has a unique solution for summation k mk. Let B denote this solution k. Now this equation can be defined as follows. Vx is equals to Fxb. Now alpha x q and lambda are parameters and Bx is uniquely solved. Thus the unique solution for Mx is as follows. Mx is equals to 1 by lambda into Bx minus alpha x q into B by n. Thus, this is the quasi-linear explanation of Groves-Ledyard mechanism. Let us now summarize what we have discussed in this module. Public goods are those types of goods which are provided by the government through budget like highways, public parks, defense, ports, etc. Demand revealing is a process where collective decisions are being made and which is being designed to choose the option of greatest value, and in this process the option is being identified by giving participants a chance to report about their intensities of their preferences honestly. The demand revealing schemes for public goods have been studied by various economists like Edward H. Clark, Groves and Ledyard. The term DR was described by Edward Clark in 1972, and in 1975 Groves and Loeb worked on this process independently. DR has been called as pivotal mechanism in economics.